Are you able to see my screen?
Yeah, good.
All right, good. Greetings, everyone. A warm welcome to the Exchanging Ideas 11th Global 5G Evolution. Kindly take a second to subscribe this YouTube channel by clicking the subscribe button. I'm 𝗘𝗃cije𝗿𝗂𝗁𝗃, and it's a pleasure to have this wonderful session with everyone around the globe. A warm welcome to the global best 5G experts today to present the most trending topic for 2021. Now to start on, let me kickstart with this program that we are planning to launch. Welcome to 5G Use Case Accelerator Summit 20th April 2021. It's an initiative by Global 5G Evolution, an online accelerator program for high potential students worldwide, and also tech startups who are solving their region challenges, be it whether to solving societal problems or economic, environmental, and health. And the objective of this event is to gather and cultivate innovative ideas from worldwide universities that involve in wireless communication 5G research, be it in data science, mechatronics, artificial intelligence, big data, Internet of Things. And we are expecting about more than 550 universities from 7 continents on this online virtual event. So the advantage by participating in this program is that this particular platform will provide the youngsters to give or to create the idea of an innovative skill in seeing what are the possible new use cases from the traditional use cases that is already commercially deployed. An average about 100 plus of use cases that is already been deployed in the industry, in the market as well. And how can we go beyond that? Are those use cases successfully implemented? What are the current issues that those use cases are facing? Or it can be a brand fresh new use case that can able to solve the current issues. It can be biodiversity issues, or it can be COVID-19 issues. So that the youngsters can able to group together. And the interesting part of this program is that it's like it can be an individual participation, or it can go up to 3 students, and those students are not necessary to be from one university or from one country. They can be from different universities from different countries, right? And that is the best part, to actually have this kind of a culture exchange. It's a kind of bringing a universal human values, diversity, equity, and inclusion. And that's how we are creating a wonderful global society by having this program. And this program we will be selecting the finalists of 8 groups, and they will be presenting on April 20th between 4 to 5:20 p.m. Singapore time. We have this a typical 5G use case template, so that the students can use that as a sample format, and it's very quick and easy 4-page, where it's under the title of how such use case can able to solve the global issues or global problem, and what are the advantages, what are the benefits, and whether it's still in the ideation stage or they have already brought to a prototype stage. And what we are bringing on this platform is a group of best experts, advisors from universities and also from industries. So far, the University of Birmingham and University of Bristol from UK professors has already accepted, and from University of Hellenic Greece have agreed as well, and Spain coming on board as well. So so far we are still looking for 5G advisors from Singapore, from Australia as well, yeah, if the speakers, you have any of your contacts from your alumni group, it will be wonderful to bring them on board as well. And this initiative is free for all the students or even startups. The invitations have been sent to most of the 5G research, innovation labs and the universities, including WITS University, University of Surrey, Curtin, Coventry, for the NYU Tandon, from Germany as well, Tokyo, all around the world as well. And we have done the first opening ceremony where we brought in the professor from National University of Malaysia to kickstart this program. And we had a few researchers from India to come on board and give presentation on how a typical 5G use case all about, and also from Nanyang University from Singapore as well, to give some sort of a sample idea of a typical 5G use case so that the students will have a better understanding. We'll have another session as well on 27th of this month where the professor from Morocco will be giving some sort of idea as well. And those are the typical traditional or standard of 5G use cases from various vertical industries. And we are looking forward for students to either look into these specific industries and see is there any other area of improvement that they can come out with an idea. We are also, since this is a non-profit initiative, we are also welcoming volunteers from the universities in order to help us to get the reach outs to as many students worldwide, globally. And one of the areas that we're really looking for volunteers is into the social medias, and we do free of transfer of knowledge and trainings when it comes to graphic designing, social media, video editing, email marketing, Eventbrite management, advertising, Canva designs, and all those stuffs. And we are also welcoming any investors or entrepreneurs to come and sign up and witness and see if some of the innovative idea can be brought to another stage, another leverage where we can do some sort of a test, or we can actually conduct a test lab to facilitate them and see if something works out with the idea to a prototype. And lastly, this particular program, Exchanging Idea Global 5G Evolution, is a YouTube platform and community providing millions of engineers with information content. We started in Malaysia, and we have also already launched in India and also in Qatar to spread the information, right? Because some of this information that is being given by the speakers are very valuable information, and it's not available in the net, right? And some of the organizers, they charge huge amount, and our initiative is we want to give it to all these university students or jobless graduates or anyone that they can able to gain knowledge, for free, right? So, and that will be very helpful for them to develop their own competence. So we have this monthly session, and we upload this on the YouTube channel so that everyone can able to subscribe and able to value those information from this YouTube channel. So basically that is overall from my side, and I thank from the presentation that I've done. Let's move on to the next speaker. Let me introduce Michael Burns from Glasgow, Scotland, to present the 5G and advanced manufacturing in Scotland.
Hello. Can you see my screen?
Yes, perfect.
Okay. So Introduce myself as Michael Burns from Research and Innovation Services at the University of Glasgow, up on the west coast of Scotland. It's one of the UK's ancient universities, founded in 1481, and one of the biggest universities in the UK. My presentation this morning will touch on some recent work that we've been doing, a partnership with the Scottish Government, a fellow university, University of Clyde, and the National Infrastructure Agency in Scotland, the Scottish Futures Trust, come together to establish a national centre for 5G. And it's the only one that we're aware of in Europe, and it may be fairly unique globally as well. Maybe you guys will know better than me. But this work comes from a recent study undertaken for us by Deloitte, pointing to some big numbers out there around Scotland's economy and the benefits of 5G. So the centre was established in response to that. It's a national centre and has got responsibility for developing and deploying 5G use cases for economic development and social benefit. Slide there. And these slides are available as well. I'll send them on to 𝗘𝗃𝗽𝗃𝗃 afterwards if anyone wants to look at anything in there. The three main things I'll talk about this morning are the national objectives of the centre, the sector-specific role that we've been asked to provide, and the global reach of the centre. Now, we report directly into the Scottish Minister for Connectivity. There is a designated minister, cabinet level, for connectivity that we are responsible to. The growth priorities that we're working to, there'll be no surprises in there. The big thing we've been asked to concentrate on is rural connectivity. Again, mentioned in my introduction to the speaker, Scotland's landmass is fairly sparsely populated. The main population centres are in the central belt, around the big cities of Glasgow, Edinburgh, Dundee, and further north than that it tends to thin out quite a bit, but a lot of the politicians represent these areas, so that our brief is to develop rural connectivity for the benefit of Scotland's population and economy. There also as a distinctive global offer, given that our expertise in rural 5G services can be traded internationally. This is the spread of the hubs that we're pushing out across the country, from the south to the central belt, then up into the north and into the Western Isles and the Isles of Orkney and Shetland, where we've already made quite a bit of progress. I can provide further detail on that if anyone gets in touch. The hubs are going to be concentrating on a range of key economic priorities for Scotland's economy. Again, there'll be no surprises in there as well. Energy is quite a big one, but this morning I've been asked to talk about manufacturing. So I'll switch to our relationship with the National Manufacturing Institute of Scotland, located out near the airport in Glasgow, and as the title says, it's a national centre of excellence for advanced manufacturing. About £60 million worth of funding as startup into that. It's a new build, it's a new campus. It's due to open, some parts of it are open already, but it's due to open formally next year. So the National Manufacturing Institute of Scotland does, again, what you would expect it to do in there, is to act as a magnet for investment and as a centre of excellence for the commercial ecosystem around manufacturing in our part of the world. Sponsored by the Scottish Government, by UK Government as well, by the skills agencies, the economic development agencies, our partner universities, Clyde, and the Scottish Funding Council, who are responsible for university funding in Scotland. The research centre, but it's also a commercial centre as well, has various specialisms within it: advanced forming, lightweight manufacturing, and the digital factory, which is what we've been working with them on around 5G in the manufacturing process. This is their critical gap, is to pick up TRL 4, 5 and 6 and then push it further up to 7, 8 and beyond. A list of the partners that they work with over at the Institute. Some information on the Transforming Research Centre and the High Value Manufacturing Catapult who are out there, and the Digital Factory, which is where we come in. So we've been doing some work with these guys on advanced manufacturing in white goods and also in the distillery sector, which is Scotland's second most valuable export after salmon, of all things. So it's very important to the Scottish economy. It's a Scotch whisky, and it's looking at process development and resource efficiency in the manufacturing process. So what we've been doing with these guys is looking at factories and looking at fitting out factories with 5G private networks, developing the use cases in there, as I said, in white goods and in food and drink. Looking at the uses of that in predictive maintenance, in logistics within the factories, especially bonded warehouses and distribution centres for Scotch whisky, and remote expert as well, given that a lot of these distilleries and bonded warehouses are in very remote parts of Scotland and require servicing from the centre, which in the past would have required someone getting in a car and driving up 200 or 300 miles to visit a distillery. That can now be done remotely through the use of AR over a 5G private network. I'm working with these guys again on some of the security testing required for network resilience. Feedback we've been getting from the sector is again 2% efficiencies out of that, leading to whichever way you calculate it, an increase in cost efficiency and saving. And that's a quick whiz through of who we are. As I say, we are a national centre focusing mainly on rural 5G, but for this morning, focusing on the high value manufacturing component to our work. There's quite a bit more to what we do. There's a website, look at contact on the slide there, but that's it for me for now. I'll pass it back to 𝗘𝘃𝗽𝗍.
Excellent. Thank you, Michael. I appreciate that. So now moving on to next speaker, Dr. 𝗚𝗪𝗪 from Frankfurt, Germany, to present on the 5G enabled real-time communications for tactile internet.
Hello, 𝗘𝘃𝗽𝗍. Hello, everyone. Firstly, I want to give a short introduction about myself. My name is 𝗚𝗪𝗪. I was assistant professor in my country in Yemen, and since 2015, I joined 𝗘𝗃𝗽𝗽𝗍 Research Institute in Germany as a researcher. I am working on mainly on the radio access network and more specifically in radio resource management. My talk today will be about some new and revolutionary technologies called tactile internet, enabled by 5G and beyond 5G. My agenda will be divided to 5 sections. In the first section, I will give short introduction about tactile internet, what is the requirements of this technology, and what is the target applications. The second section will be assigned to what is the real-time communication that the operator of tactile internet, and then what is the enabling technology, and before finally I will explore briefly my work in current work in 𝗘𝗃𝗽𝗍 in our current work project, and conclude this talk. Okay. As you see in this slide, we see the tactile internet is a natural evolution of the previous internet technology, which started by fixed internet and then by mobile internet. Mobile internet appeared in the third generation mobile broadband, and the main key performance indicator will be the throughput, because it requires very high speed that communication free high data rate, and then evaluated to the Internet of Things. Internet of Things, I think it appeared by 4G and supported by machine to machine or machine type communication. The main key performance indicator will be system capacity, because the machine added to the human in the communication, and the number of devices is huge. So the main key performance indicator is system capacity. Then now in this generation 5G generation, and still under development for beyond 5G and 6G, is the tactile internet. What is the tactile internet? The tactile internet simply is the communication network that is keep able to transferring or to transfer in addition to voice and video, as in mobile internet and Internet of Things. Of course, Internet of Things is interesting by the data between machines, control data, sensing and activation. But in tactile internet, there are another dimension added to the transmission or the communication, is the communication of control and touch and sensing actuation information in real time. The main requirements of the tactile internet that must be supported by haptic communication. Of course, haptic communication is the general term of ultra variable low latency communication or real-time communication. The main requirements will be 1 millisecond or less round-trip latency, ultra-high reliability, bit error rate equal or less 10 power to 7 -7, ultra-high availability 19.999%. Of course, the security is required and privacy, because the transmitted information here is critical between critical machine as autonomous driving, as shown in the applications in the right side. Robotics and manufacturing, healthcare, autonomous driving, education and supports, virtual reality, augmented reality, and extended reality. This all application depends on ultra reliable low latency communication and haptic communication that is enables tactile internet. Here, the architecture of the tactile internet, the communication network that support tactile internet, is divided to 3 domains: master domains on the left side, that operators and physical operator with tactile human system interface exists. And in the other side, in the right side, we see the tactile edge device robots, composed example given remotely controlled robots. This is called controlled domain. Between the domains, we are interested as a communications researchers in the network domain, how to design this network to support the requirements of the tactile internets or the haptic communications. On the left side, we see the core network and internet that is transport network. You see it is firstly is wired network. In the next slide, we see it was replaced by wireless network, and the the other network is called the telecommunication network that composed radio access network and part of the core network as packet gateway and surface surfing gateway. Because the tactile internet require low latency, ultra low latency communication, the latency budget in the lower will be 1 millisecond, as I explained before. At least 1 millisecond end-to-end latency. Then this latency is divided between terminal and air interface and base station control and steering server. Of course, the latency include not only the communications connectivity, but also the computing and the storage, the caching. But we are focusing on the networking latency. Our target is to minimize the transmission latency, the wireless transmission latency or the air interface latency to the minimum of, as you see in this dotted square, 200 microsecond end to end. I mean end to end in the radio access network, not in the overall network. The best reference for explaining the tactile internet and the architecture requirements technology is written below by Mariam Simsek and others. Here in this slide, I think it will the same of the previous slide, except the wired network in the master domain is replaced by wireless network. There are two radio access network, one in the master domain and radio access network in the in the slave domain. Excuse me, in the slave domain. And there are the network domain between this networks to close the control loop is called here in the green color. It's called global control loop. This is a bidirectional control or bilateral control signal, and it must be in the limits of the 1 millisecond. We see also the intelligence or the computing in the edge is transferred from cloud to the edge, and include also the intelligence. Why? Because the physical distance between the operator, physical operator, human or physical operator, to the teleoperator, the robot, slave robot, it is very sometimes it will be above the above the range of 1 millisecond. So there are intelligence in the edge, or can be distributed from cloud to the edge to the device itself in so-called FOG or FOG radio access network. This intelligence or this machine learning algorithm predict the behavior of the other side and can mimic this behavior to transfer the control loop from end to end will be from the operator to the edge or from the operator to the edge. This constructing local control loop at each of the sides of the tactile internet, and then will satisfy the requirements of tactile internet. What is the technology that can be facilitate tactile internet or the real-time communication? As we see in the slide, the traditional radio access network that will be was in 4G and before is divided in late 4G and 5G uh, to from to network or disaggregated by two technology: software defined networking on the left side and network functions virtualization. This technology enable so-called converting the communication network to softwarized, or we can call the flexible and abstracted programmable network, as you see in software defined networking. Uh, Disaggregated the network to plane, data plane and control plane, and in network functions virtualization divided or discreted the network to software and hardware, make the radio and the infrastructure network available for all function in software that can be programmed or controlled by software-defined radio controller.
Excuse me, doctor. Due to the time factor, would you able to wrap up?
The time is near. Okay.
Yeah.
Okay. The computing will be brought from cloud to the fog, and here is my our techniques in our 5G remote. It is a DFG funded project under grant number 674795, and we see the end-to-end communication from the master to slave. It is bidirectional across ultra reliable and ultra responsive network. The main requirement is joint resource allocation, uplink and downlink in a necessary. A bounded daily requirement must be considered during resource allocation, because in this scheme we combine or we use the artificial intelligence and forge radio access network to build advanced radio resource management to support the tactile internet. The other requirement, minimum rate must be guaranteed for haptic session. Haptic communication requires symmetric resource allocation. And finally, our scheme is divided to three sections: dynamic resource slicing. The whole resources are virtualized and sliced between the vertical surface between tactile and non-tactile. Resource isolation between tactile and non-tactile, as I mentioned. And after the slicing, the resources, radio resources and infrastructure resources are optimized or allocated in each slice according to the surface requirements. The conclusion: tactile internet is the future communication network for real-time communication. Critical machine type communication use case of 5G has supported partially internet, tactile internet. I mean, in this statement that tactile internet is already supported by 5G, but partially. There are still some challenge to be mitigated or to be researched. Tactile internet will be fully realized by enabling real-time communication over 5G beyond 5G. 4G RAN, network slicing, and artificial intelligence are the key enabling technology for real-time communication. And finally, 5G remote is a DFG funded project to build intelligent radio resource management for tactile internet. Thank you.
Excellent. Thank you, Dr. Najib. Appreciate that.
Thank you very much.
So moving on to the next speaker, let me introduce 𝗚𝗃𝗽𝗀𝗃 from Sydney, Australia, to present on the 5G radio access network architecture.
Hi guys, am I audible?
Yes.
And you can see me as well?
Yes.
Okay, great. Okay, this topic. Hi guys, my name is Nav. I'll be presenting on 5G radio access network architecture overview. I work for Ericsson, and this is something I'm very passionate about, as the evolving radio access network architecture is something I'm passionate to sort of train people on. Move on to the next slide. This is my agenda slide. Basically, I'll be starting off with covering mobile network evolution. How have networks evolved? I'll be also covering some fundamental understanding of what mobile network architecture looks like. Then I'll move on to the evolution drivers, next generation 𝗃𝗃 architecture and interfaces. How do we connect to the 5G RAN? And also comparing non-standalone versus standalone, and how telcos can migrate from a non-standalone architecture to migrate to standalone architecture from a non-standalone architecture. And finally, we'll tap it off with a comparison of centralized, distributed, and virtualized RAN. Just starting off with some fundamentals, mobile network evolution. So basically, how has the mobile network evolved from 1G to 5G today? Initially with 1G, it was basically analog speech. Then we moved on to GSM, where we started with digital speech, and we're able to send essentially voice signals across the GSM network so people can start communicating. And finally 3G, which was sort of 2004 onwards. There were various standards that came into being: WCDMA, UMTS, etc. LTE which is still quite prominent in today's age, and obviously 5G, which is the future, and it is the current present as well. So just fundamentals of mobile network architecture. Basically, we've got the core network, which is basically where your billing, your packet core and voice core reside, where your connection management happens. You've got the RAN, which is going to be the prime focus of today's topic, where you have radio and baseband hardware and RF to provide wireless connectivity to the user. So this is where the user will talk to the RAN via the air interface. And finally, your user equipment or your mobile phone. So let's firstly try and understand what are some of the drivers. Why are we having this architectural transformation towards 5G RAN from LTE and previous generations of mobile networks? First of all, it's the growth factor are the 5G verticals. There are many new business use cases that have arisen from 5G RAN, including virtual reality, low latency communications, vehicle to vehicle, interactive gaming, etc. These use cases can be realized only with effectively a 5G RAN and also a 5G core, which we'll also cover later on. The cost factor, there's a push towards automation, low cost and simplicity. The telco cost, the total cost of ownership is something we want to lower. Telcos are paying a lot of money for their network investment, for their RAN investment, and possibly things like virtualization can be looked at in order to lower the cost. And obviously the changing architecture towards software-defined networking and network function virtualizations, where the software and hardware are decoupled. Obviously spectrum and capacity. With 5G, we have higher frequency bands, which we call millimeter wave. So how do we actually leverage the existing low band and mid band spectrums of LTE and also use that as an anchor and use NR high frequency for millimeter wave communication? Effectively, what that allows for, what 5G spectrum is, it allows for is a wider bandwidth and improved coverage. Now let's cover on what the 3GPP architecture looks like for a 5G radio access network. Basically, you've got your next generation core, you've got your G-Node B, which is your 5G base station, your E-Node B, which is your 4G base station. They're connected to the 5G core. This is typically a standalone scenario, but it's sort of the scenario we use to describe the next generation RAN architecture. We also have, obviously, connectivity between G-Node Bs and E-Node Bs via X2 or XN interfaces. This is obviously required via the backhaul network. Obviously, with the introduction of new interfaces, we've got N2 and N3, which are the control plane and user plane interfaces connecting to the 5G core. Just further on the interfaces, basically with 5G, with a non-standalone solutions typically, which we'll talk about more, E-Node B talks to the AMF, which allows for the control signaling to happen. So when a call is set up, the signaling needs to happen first to the access mobility function. And then obviously the user plane, which passes through the UPF. So we're using effectively LTE as an anchor, and we can pass signaling through that. Or, but specifically, if we talk about 5G core elements, it's an AMF. But whereas with the packet core, it's an MME. But specifically in this case, we're talking about AMF and UPF. So these are our next generation control interface and next generation user interface. Now, if we look at the connectivity options, there's various UE connectivity options to connect to a 5G RAN. You've got option 1 where you've got LTE connected to your 𝗵𝗵𝐶, which is what your traditional LTE network architecture. Option 2, which is your 5G, specifically your 5G NR radio access network connected to your 5G core network. And that what we call non-standalone, where you have E-Node B and G-Node B both connected to the 𝗵𝗵𝐶. And basically when the UE is trying to establish, it uses LTE and NR as a master and a master cell group and a secondary cell group in order to connect. Option 4, which is typically your NR connecting to your 5G core. Option 5, which is less popular, but option 5 is your LTE connected to your 5G core. And then option 7. All right, so let's have a bit of a comparison of non-standalone versus standalone deployment options. Effectively, with your non-standalone, you've got interworking between LTE and NR, which as we've discussed is option 3X. And basically, when the UE connects in a non-standalone fashion, it's called EU-TRAN dual connectivity because it effectively connected to 2 base stations at once. With a non-standalone, you have 𝗵𝗵𝐶 at the core or the 5G core as well, or the evolved core. We use a layer 3 control plane termination in LTE for basically, as we discussed, signaling, and then user plane termination in LTE, NR, or basically both. With a standalone option, your GUI connects purely to NR, so there's no 𝗍𝗏𝐵, there's no LTE there. You specifically require a 5G core, and your 4G and 5G RAN are effectively decoupled from each other. Now, if a telco wants to migrate from a non-standalone to standalone architecture, they obviously need to have a strategy around that. In order for the early deployment to happen, initially you would be connecting via option 3, where you're having your 𝗍𝗏𝐵 and 𝗍𝗏 LTE providing you extended coverage, and obviously you also have your NR coverage, but it's all connected to an evolved packet core. The next step option could be option 7, where you introduce a next generation core. You keep your radio access network the same. You have your 𝗍𝗏𝐵 and 𝗍𝗏𝐵, and finally you can migrate to option 4 and or 2 via this architectural shift where you purely have NR connected to your next generation core, so there's no LTE base stations present. In terms of your non-standalone overview, let's just discuss what that might look like for a customer trying to deploy 5G. Basically, you're leveraging on LTE low band and mid band to overcome propagation challenges, because obviously with high frequency, there's more path loss, there's more propagation challenges, but you can also leverage off NR for the high band as well. It's usually your first step in NR deployment. This is how you connect initially for any telco. So all telcos around the world would normally be starting off with an option 3X model. You can have your sites co-located or separated. So you can have your LT and NR sites co-located on the same, effectively, like the baseband hardware and the radio hardware could be in the same site, or you can have different sites. This obviously, as we've mentioned, this architecture is transformable to a standalone architecture. What the good thing is also is if you've got spotty NR coverage, you can use LTE coverage to service the UE. And effectively, you can use spectrum sharing where 4G and 5G spectrum are shared, and that would effectively give you things like carrier aggregation, and which would improve your capacity. So yeah, and standalone. Well, with standalone, you specifically require a 5G core. Your 𝗍𝗏𝐵s are connected to your 5G core using your next generation interfaces, and obviously your X and X2 to connect between 𝗍𝗏𝐵s. It obviously supports network slicing, so that's where your use cases come in. A lot of the use cases of 5G come in due to this ability in the 5G core. You've got lower latency communications. It's traditionally a service-based architecture, which is a slight shift from your LTE, which is usually you've got 3GPP-based interfaces, whereas with a service-based architecture, you've got HTTP-based interfaces. And target architecture for new 5G use cases with 5G and NR. So if we look at the architectures in itself, we can divide it into 3 main components. One, which is a distributed RAN, a centralized RAN, or a virtualized RAN. With a distributed RAN, this is your traditional RAN architecture, where you have on the same site, the antenna, the radio unit, and the baseband unit, and you've got your 𝗬𝗎 connection, which is your optical connection going into your radio unit, which is, the 𝗬𝗎 is usually the length of what you would install in a tower, and you traditionally have a backhaul network going into your evolved packet core, also called a transport or transmission network. So this is highly distributed. So what that means is like all the sites are separated. You do have some advantages there in terms of managing it. So it's not a central point of failure, which you might have with a centralized RAN. So there are, and most of the telcos actually use a distributed RAN model. Now with your centralized RAN, you've got a baseband hotel where you have all your basebands in one sort of a data center you can compare it to a data center because it's very centralized, and effectively you've got a front haul interface going into your radio unit. So the only thing that would be site specific would be your radio units, which be deployed wherever your sites are. But all the baseband hardware is present inside your baseband hotel, and obviously you have your backhaul. And finally, your virtualized RAN, where you're using commercial off-the-shelf hardware. It's a split architecture. It's in terms of the layer 1, 2, and 3. There's SDN and NFV highly present in this model, and we also call this it's one of the prime architectural derivatives of Cloud RAN. So this is where you've got a lot of the infrastructure being cloudified or sitting in the cloud, apart from your antennas. So
excuse me, enough.
Yep.
Wrap up. Yeah.
Yep. Concluded for the presentation. Thank you so much for your time.
Oh, perfect. That was right on time. Thank you so much. That was a brilliant presentation. Appreciate that, Nav.
Thank you so much. Cheers.
So yeah, moving on to the next speaker, Patrick Koh from Singapore, to present on 5G private network in manufacturing, logistics, and ports.
Hi, 𝗂𝗃𝗽𝗃, can you all hear me?
Yes.
Okay, so I'll be sharing my slide. Thank you, 𝗂𝗃𝗽𝗃, for the invitation. So today I'll be presenting and sharing a story, a little bit about the digitization towards Industry 4.0, primarily leveraging on the industrial grade private wireless network. So my name is Patrick, I'm from Nokia. So I'd like to touch base a little bit in terms of the business challenges as we see today in a market, in the enterprise market. We're actually quite in tune with a lot of industry verticals. So just for the purpose of this sharing session, using energy, transportation, and manufacturing an example, we see across the board there seems to be an increased use of autonomous guided vehicles, which either historically been using Wi-Fi, and with the advance of technology from 4G to 5G, most of the Wi-Fi related issues are being resolved as we speak in terms of increased reliability. So we see that across the board in energy sector, in terms of the dump trucks, manufacturing, in terms of the AGV, as well as ports, a lot of autonomous guided vehicle trials going on there as well. In areas of airports, we see that there is a demand in terms of the airport operators to have a seamless connectivity within the entire airport as well as inside the plane itself, right? So this is one area that definitely 5G can support. One area of interest, what we see is also the increased use of camera, 4K video cameras and analytics, which will drive a lot of use cases. So as these enterprises come up with all these new innovations, there are typically a few trigger points that they will want to adopt a private network versus leveraging on the public network. One of which is the limitations of Wi-Fi, mainly due to reliability. So one of the things I would like to highlight is that we are now talking about mission critical operational business applications, right? So this is one area that is our main segment. So Wi-Fi, there's a challenge in terms of the reliability. The much increased use of autonomous vehicles, which needs also definitely much lower latency. There is a demand for better security across the board, which will drive the conversion. and as well as access to fixed broadband. So in most cases, or in some cases, whereby broadband, the last mile for broadband is actually pretty expensive and it's not easily available. So this is where wireless connectivity will help. So to address these gaps in technology and business challenges faced by our enterprise customers, so we actually offer 3 types of solutions, right? All depending on the needs by these enterprises. So on the left-hand side, you see the enterprise autonomous private wireless network, whereby it is typically for large-scale enterprise, whereby they can actually buy, own, and operate by themselves, really quite autonomous. And you have the probably the small and medium-sized enterprise that they just need the connectivity as a service. They really don't want to meddle with too much of this technology, but they want to use this to leverage and run their applications. And of course, some are running via the public operators network as a service. So there is a full suite of solutions based on the requirements of individual enterprises that we talk to. So of course, nowadays, the big hype is on 5G. But technically speaking, most of the applications can already run on existing 4G technology. And we see very specific emerging trends of use cases that will need, for example, 10x bandwidth than before, or 1/10 the latency. And these are clear use cases when it comes to the XR, AR, VR, MR type applications, the AGV type, teleoperation type applications, whereby you need a sudden surge of high bandwidth and very stringent demands in terms of the latencies. So most enterprises that we come across, they are actually more focused in running their business operations. They do not want to spend so much effort trying to meddle with technology. So in that case, we would like to offer them a lot of flexibility, from a on-premise solution or cloud solution. We can offer them if they would like to run on their own or just buy it as a service. We can have a CapEx model. We can have an OpEx subscription model as well. Depends on the financial requirements. But most importantly, how I feel is that it is beyond technology. It is really about the use case. And it is really about how we can help the enterprise customers improve their operations. So in that sense, what we have is a very stable suite of blueprinted solutions which have been implemented. We can easily cookie cut and customize for the individual industries so they can implement it quite fast. Beyond just technology, it's about running mission critical applications for our enterprise customers. One good thing about this solution, the beauty part, is that it is actually interoperable with the public cloud. So as our enterprise customers may have their applications residing with maybe Google, maybe Amazon, maybe Microsoft, we have the ability to interoperate with these public cloud applications. So for the purpose of sharing, just going to share some practical applications on the field. So in terms of the areas of logistics, so what we have is the Alibaba, whereby you can see, they are shipping out millions of parcels, and they really need a lot of automated AGVs running around. Of course, it is whereby Wi-Fi have its limitations and they are switching on to LTE. We're also implementing this for the Vienna airport. Essentially, it's about seamless coverage everywhere, from the terminal, airside, curbside, to the plane, to within the cargo plane, inside the cargo itself. So, all this needs very seamless network connectivity for the applications to run. So this is one area that they are really, really concerned about. Our collaboration with Port Oulu is the same, whereby there are quite a few legacy network running on different applications that they're trying to harmonize the applications on one consistent connection network platform. Coming to 5G is a very new topic. All these applications and use cases are within the last 12 months. So we have Lufthansa essentially leveraging on AR/VR applications to remotely inspect their engines under the maintenance, repair, and overhaul services vendor. We're also working closely with Sandvik, essentially an equipment maker, to provide AGV for mining as well. So you need really high reliability and very, very low latency to support these kinds of actions. We see the transformation of manufacturing and assembly plants, converting their lines to be very, very mobile to very, very small lot size, and using leveraging 5G technology, as well as a rail operator in Germany. What is important to understand is that it is actually beyond technology. It is actually about the whole ecosystem, the whole suite of applications that will provide increased productivity, digitization of the enterprise operations. So we do have a broad collaboration with a broad ecosystem partners to support our enterprise customers. So I believe my time is soon up. Essentially, the enterprise private wireless network is all about providing mission critical connectivity and applications, right, as we support our customers towards their Industry 4.0 journey. Right. So with that, I will conclude. My name is Patrick. Please feel free to drop me a line, patrick.𝗂@nokia.com. Thank you, Ganesh. I'll hand over the mic to you.
Awesome, Patrick. Thank you so much. I appreciate that. So now moving on to the next speaker. Let me introduce 𝗬𝗪ci𝗍 from Victoria, Australia, to present on 5G, AI, IoT, digital twins will change manufacturing.
Thanks very much, Ganesh, and thank you for allowing me to speak this evening on this topic. I just want to give you a little introduction of myself. I've worked for probably the last 30 years in the telecom and IT industries, and more recently, over the last 2 years, I've been very focused on digital transformation of selected sectors. And so I currently work for a company called 𝗀𝗪𝗍 in Australia, and we help different business clients realize the value of technology and how that can transform their business. Currently, we're focused on smart cities and construction, as well as manufacturing sector. But today I wanted to talk to you about manufacturing sector, and I want to take a little bit of a different tact. I don't want to talk so much about the network itself. I want to talk a lot about what are all these technologies that are really transforming the manufacturing sector, and why is 5G needed for manufacturing? So, like every sector, manufacturing is really undertaking a major transformation. And I think Patrick talked a little bit about Industry 4.0 and manufacturing, and this has been around for a while, but I think this is only the start of it, and we are going to see significant digitization of this sector. And COVID, if anything, has really spurred on the need to do this digital transformation. Because with COVID, what that has meant to manufacturing is that we have a lot of people shortages and a lot of needs to socially distance in manufacturing plants, which means that we need to really build manufacturing plants in the future that are much more automated, where the manufacturing processes are streamlined, and we have things like robotics and tools to manufacture, to support the manufacturing of these goods. So people shortages and social distancing are an issue at the moment in plants, but the supply chains have also been disrupted a lot because of COVID. And that really is a statement of some manufacturing plants shutting down because they are no longer needed to manufacture goods, and some ramping up in major ways. And that's because of things like panic buying, or, you know, some manufacturing plants have redesigned themselves and now become, you know, mask manufacturers, which they weren't in the past. So what we're starting to see with manufacturing is really the need for manufacturing plants to become much more agile, and they need to be equipped to change rapidly to meet the customer demands. And the only way to do that is to automate processes. The third thing that I think COVID has meant in manufacturing is a number of countries around the world are now trying to re-energize manufacturing within their local market. And this is a statement of trying to reduce reliance on other countries' manufacturing products and goods, but equally it's a focus on trying to generate more employment with jobs having been lost, and drive economy and create small businesses again. And so I think because of COVID, we're likely to see a lot of change in the dynamics of the global competition in the manufacturing sector. And I think digital technologies will in fact become more of an equalizer. And I find this very strange because when we usually talk about equalizing in telecom industry, we talk about, you know, using technologies to make emerging markets the same as developed markets. But in this case, in manufacturing, I think it's the reverse. I think it's the fact that digital technologies will enable developed markets to actually now participate in manufacturing again. Previously, it was unaffordable due to labour costs. So I think COVID is spurring on a lot of the digital transformation that we're about to see happen in the manufacturing sector. And what I want to do is really talk a bit about what are the core technologies that are driving this transformation, and why do you really need to have 5G versus traditional networks of Wi-Fi or LTE or whatever. So when I look at manufacturing, I usually think of the technologies fitting into 4 key areas. And the first area is around advanced analytics and intelligence. And the main piece of that is really machine learning and AI. Now, I know if you've been reading a lot of press lately, you'll see that machine learning and AI is being considered as a major revolutionary technology that will change the way that we live and work in the future. And I think that's a really, truly a fair statement, because I think it has potential to really change processes and really change how different industries operate. Of course, we have had artificial intelligence for some time now. This is not new, but what really has changed is the technology behind artificial intelligence. And we are now seeing this new technology that they refer to as deep learning. And what deep learning is the way that a machine learns, and it mimics how our brains learn. So it allows the machine to really be able to detect objects, to recognize speech and facial patterns, and to make decisions just like our brains do. So if I applied this to manufacturing, I would think of an easy example being driverless vehicles or drones. So every manufacturing plant has some degree of equipment that delivers goods to the manufacturing line and takes goods that have been processed into warehouses. And so if I think about a driverless vehicle in a manufacturing plant, then these vehicles really need to be able to go out and assess the terrain of the manufacturing plant and understand if there are objects in the pathway and what they would do if they encountered these objects. So that's an example of what artificial intelligence could mean in manufacturing. Another key technology that started to emerge, not just in manufacturing, but many sectors, is the application of digital twins. And what digital twins will allow us to do is to create a virtualized image of a manufacturing floor or a manufacturing process. And from this, we can actually decide, you know, how we can improve those processes or you know, what we need to change if we want to change the manufacturing line itself to create new products. Digital twins, that, however, requires a lot of data. And so it does use some form of artificial intelligence, but it also is using IoT and IoT sensors to capture that information in real time. And the digital twin then is analyzing the data. So in manufacturing, digital twins can be used for a number of different things. They could either be used in terms of designing new products and new processes in manufacturing, or they could be used in creating a digital twin of the production process itself to understand when they should do plant outages, or if there's a potential plant outage that's likely to occur, or should they upgrade their plant, which in production and manufacturing is critical, because that's where a lot of money is lost in plant outages. They can also use digital twins to optimize things like warehousing and supply chain processes. So once I have the goods, where do I warehouse them? You know, who's going to pick these goods up? How's it going to get transported? Those types of processes. So those are two key technologies that we're seeing emerging around the areas of analytics and intelligence: machine learning, artificial intelligence, and digital twins. The second area, I think a lot of us probably understand quite well, which is being called human-machine interaction. And some of these tools around there, there's two core tools that manufacturing processes use, one of which is robotics. And we all know that robotics has come a long way over the past 20 years. And nowadays, what we're seeing being referred to in manufacturing is what's called not just robots, but cobots, meaning collaborative robots that work alongside humans. So what these cobots tend to do, things like they assess the quality of the products that are coming down the manufacturing line, or they might be involved in picking and packing the products, or they might be involved in welding different things, or packaging, you know. So there's a lot of these new robotic type automation tools that manufacturing lines are using today. Virtual and augmented reality is another area that is making its way into the manufacturing plant. And some of this virtual reality is being used to detect bottlenecks and areas for improvement in process flows within the plant. So they're creating a virtual environment and doing like what if analysis around what if this occurred, where would the bottlenecks be? I think one of the more interesting cases was, I was reading recently, was that Ford is using virtual reality and augmented reality on its production line. And it was actually able to reduce the employee injuries by around 70%, because they were able to identify potential danger areas within the production line. So it's also used for safety, and it can be used, you know, to help train operators in different areas of production line. Chatbots is also being used to communicate with people in the manufacturing process. So there's a lot of technologies around human interaction, probably more than this, but the core ones would be the robotics, the virtual and augmented reality, and the chatbots. And we're seeing chatbots also emerge in every sector, you know, because every sector is using chatbots to communicate with their employees as well as their customers. So the third area that I think there's technologies in the manufacturing sector is clearly in warehouse and supply chain. At warehouses, then we need to have logistics systems, and we need to be able to track and trace where all of the pallets, where all the goods are going, what trucks are these goods being, you know, dispatched to. So a lot of IoT is finding its way into warehousing and supply chain, as well as blockchain. And blockchain is being used in supply chain to really do supply chain traceability. So if we have a number of players in a supply chain, which is quite common that we do, we might have the manufacturing plant, we might have a trucking company, we might have a warehousing company, we might have somebody that then delivers those goods to the end consumer. So many different players. I know when I order things online, often from the US, I can see how many different hands that goods has gone through to get to me at home. So blockchain enables the integration of all of those different players so you can track and trace goods through that supply chain. So a lot of technology is occurring in warehousing as well as supply chain. And as I said before, you know, all of these technologies, these three sets of technologies, whether it be AI or virtual reality or robotics or supply chain, all require a lot of data. And the data needs to be captured and analysed to make intelligent and informed decisions. So as we look at manufacturing, there will become a vast number of data capture points. So they're the obvious points. They could be the autonomous vehicles. They might be people with wearables. They might be robotics. It could be warehousing. It could be trucks. It could be anybody. But there's going to be a lot of capture of data, and a lot of this will be done with two key technologies, which brings me to my fourth area that I think is critical to manufacturing, and that is the combination of IoT and connectivity. So I think most of us probably understand what IoT is. It's you know, in the manufacturing industry, it connects industrial devices and sensors and equipment, and it allows you to gather and exchange information. And sometimes, if the device is smart, it might allow you to control that device as well. Well, I would say that we have had IoT in some form in manufacturing for quite a while now. And, you know, even probably 10 or 20 years ago, we had many different, what we call SCADA systems that would capture information from particular devices, but there was really no standard. So everything was very siloed. What really the new IoT is bringing to us is a set of standards that enable us to communicate with devices and control them in a better way. And we're also seeing the ability now to capture that data and to allow data exchange to occur. So IoT is the real enabler of the capturing of the data, but it is the network that allows that to occur. So today's traditional connectivity technologies that we all talk about, like LTE and Wi-Fi, you know, and LoRaWAN, and even Ethernet, you know, are all kind of present in manufacturing. You know, the question is, if I need to connect all these devices, if I need to make sure that all of these technologies are really running manufacturing, then the network of the future, the wireless network of the future of manufacturing really needs to be low latency and high bandwidth. It really needs to be able to handle that really high cell density to support that massive number of IoT implementations. And it needs to be very ultra reliable and secure, because the entire plant is really going to run on this 5G network. So it may not be here today, but 5G, I think in the future, will become the standard for manufacturing connectivity. There's many new technologies will change the manufacturing process, making it definitely more efficient, more agile, more safe, you know, and these technologies will make an equalizer. So I think the manufacturing companies that implement these types of technologies will end up being the winners. So 5G and IoT will be the key enablers. And that's, I guess, why we hear lots of companies around the world, like STL Partners, predicting that 5G could unlock 740 billion of value in manufacturing in 2030. You know, I think we live in an exciting time, and I think manufacturing is definitely going to transform, and we'll really see major gains through all of these new technologies. So I'd like to thank you for listening to me this afternoon. And I believe that one of my fellow speakers, Barry Lerner, is going to talk a lot more about networking within the actual plant itself. Thank you.
Thank you. So you have nailed it. You have covered almost everything in the manufacturing sector. Appreciate that. Thank you. So let's move on to the next speaker, Jody John Jimenez from Geneva, Switzerland, to present on 5G private networks, 8K, 4K media production.
So thank you very much, and hello everybody. So I have prepared a presentation from our association, from the 5G Media Action Group, dealing with the use of non-public networks for media production. So we are actually having a look at the use or the applications of 5G across the media value chain, and that involves from content creation to, let's say, consumption. And then, well, there are several aspects that we are looking at. In terms of media production and contribution, so, well, there are many scenarios in which at the moment, given the evolution of the technology towards IP, well, we are seeing the needs of having connectivity, or the needs of connecting equipment, cameras, microphones, in-ear monitoring systems, and so on, to the, in this case, the 5G network. So we believe this can change the way to create content. This can make the workflows more flexible. This can make the setups, let's say, less cumbersome. 5G, as we know, may provide high bandwidth, low latency. Actually, we need both at the same time. That's a peculiarity of these applications. And well, there is an opportunity, as I said, of improving many aspects of how media content is at the moment produced and created. There are possibilities to enhance current cellular bonding systems, where reliability is ensured by, let's say, replicating several signal paths. Well, there is a possibility to enhance this and enable some kind of quality of service flow, so that well, we ensure that the media traffic reaches the TV studio, for instance, with the bandwidth, latency, and integrity that is required. When it comes to standardization, our members are working at the moment. They submitted the requirements for several use cases, as you can see on the screen, from audio, video, also, well, immersive media in terms of involving audiences and so on. This is part of the SA1 collection of requirements and use cases in 3GPP. You can find here the specification where all of this is collected. And now it's time, let's say, to realize these different use cases and to analyze how 5G can bring them to reality. So one aspect of many that we are having a look is the use of non-public networks for media, as I said, and we see, well, the opportunity to provide traffic isolation, to be able to tune or to shape the 5G network to actually the requirements of the media industry, that in general are a little bit more stringent than those of public networks for design more for general purpose. There is an opportunity to provide security and privacy features on this network, so that well, we ensure that everything happening inside the network stays there. And, well, an opportunity also to manage the network yourself, where perhaps there is no 5G coverage, or, as I said, where the 5G network that is there cannot meet the requirements for media. So we see several scenarios: media campus involving studios, TV sets, sports and music venues, news gathering, or mobile journalism. And in principle, well, we are at the moment studying different models for deploying the non-public networks as defined at the moment in 3GPP. And, well, we have found these two aspects, right? The standalone non-public networks, where everything is done, let's say you create your own local area network and isolate it from any other thing. and when, or other scenarios when, well, it may be favorable to integrate some of the capabilities of the non-public networks together with an existing public network, if that's the case. To give some examples, on the standalone non-public networks, I have just taken a scenario that is described in this document that I presented from 3GPP. Is about audio streaming in live performances. So in this case, what you really want is to create a network, a local area network with very, very low latency, so that well, the traffic does not need to go to somewhere else and come back. You need a very low latency for return, for in-ear monitoring, so that, well, the performers can hear what themselves actually and what's going on in the scenario. So that's an application where we see standalone non-public networks playing a role. Also, well, the ability of addressing devices locally, connecting your own devices and being able to control them within this network. But there are also other alternatives or other scenarios in which, for instance, in this case, for live production, integrating services for the audience, or where you want to involve the audience present in the performance to, well, either to get content from them or to provide content to them. Well, there is an opportunity also to integrate some of the capabilities together with an existing public network. So with the existing public network where all these users are connected to. Well, we have started analyzing and trying to figure out how to deploy the standalone non-public networks. Well, this is a graphic of one of our explainers that we have made in order to look at this. There are several aspects that we are analyzing. The provision of connectivity in terms of, for instance, having your or not using SIM cards but network addresses, so that the equipment can actually be connected via modems without the need, or I mean without your control of how these devices are authenticated and provisioned in the network. Here, from, as I said, from this standalone NPN scenario, what we highlight is the possibility to ensure, to customize the quality of service in those areas in which a public 5G network may not be able to meet the requirements in terms of low latency, uplink and downlink ratios. Have a look that for cameras and so on, what we need actually in these scenarios is a lot of uplink, a lot of throughput in the uplink, and very little in the downlink, which is actually the contrary that happens in a regular network. We also, well, we want to highlight the possibility to isolate traffic, to isolate device subscription data, so that this is managed by the media organization, let's say. Aspects around security and integrity of the traffic that goes on this non-public network. Well, later on, of course, you can enable connectivity from outside for remote production, for remote control, and so on. But at least, well, there are some activities that require some kind of security and integrity within the network. Operational management can be done by yourself or by a third party. Well, when the 5G network, as we said, is not there, well, you can build your own network to fit the requirements of the performance, of the scenario, of the use case. Well, we are also analyzing what the aspect of cost. It's clear that if you use an existing network, that's going to be cheaper, but well, we are analyzing what the cost of this kind of standalone non-public networks could be, and so on. And also another important aspect is access to spectrum. So we know, for instance, in Europe there is national regulation around some licenses for private use of 5G spectrum given to industries. Well, can we leverage this also for media, so that we can use our own frequencies at the place where this is happening. So we are analyzing some models. And of course, for public network integrated MPN, so when there is a public network there, we are also having a look at the different possibilities, or possibility to share infrastructure or to share the RAN. So, well, first of all, infrastructure, if it's there, for instance, in a stadium or on the street, and also the possibility to actually also use the radio carriers of the public network, not just the infrastructure, but to rely on some of the connectivity that is there. There are different degrees of integration, I would say. Another possibility is also to make use of the control plane or for the signaling, mobility management, whatever, of the existing public network, but your media or your user plane flow where the media data will be transmitted, well, it remains still local to the non-public network operator. And well, a third element or a third option for deployment is the use of a non-public network hosted by a public network, for instance, via network slicing. And in this case, well, with an appropriate service level agreement, when you can perhaps realize some of the, not all, we believe, but some of the use cases that, well, those that the public network can actually meet. So these are the different areas, these are the different scenarios that we are exploring, that we are analyzing in terms of the functionality of the non-public networks for media. We are publishing some material coming from 3GPP and from the involvement of our members in 3GPP. They are available in our website, and in the end, well, what we are trying to do together is to build and to understand, well, to build applications, to build use cases, and to understand how 5G for media can be brought to the market, right? And how to shape the technology so that the requirements of the media industry are met in future networks and in future deployments. So thank you very much.
That was an excellent presentation. Thank you, Jody. Appreciate that. Let's move on to the next speaker. I'd like to introduce Barry Lerner from Sydney, Australia, to present on 5G indoor building coverage, next gen manufacturing.
Hey, can everybody hear me?
Yes.
Okay, great. So a quick background of me. You know, I work with Sue. We work at 460 Degrees. And I grew up in AT&T Bell Labs, and then ended up coming over here to Australia and became the Huawei CIO. So I'm pretty well familiar with the 5G and you know what we could do with it. And I left Huawei about a year ago and came over to 460. And I also opened up a company called Bear Broadband, where we sell smart poles here in Australia. So today, I'll talk a little bit about, you know, 5G and in-building coverage. And it's an important thing because about 70% of all the mobile data consumed right now is indoors. So first, let's start to look at the future buildings and the precincts and everything and understand what that's all about. You know, right now we're looking at what we call these 5G next generation smart cities, smart stadiums, smart hospitals. Everything is under the guise of 5G, but it's under the guise of smart as well. So, you know, but with manufacturing, there's going to be a lot of unique requirements that are going to be here because, you know, with manufacturing, it's going to mean that these production lines in the warehouse and logistics have to be very precise. As you go down a production line, the robots, you know, they do things. It needs to be monitored. Rhythms need to be understood so that if something is off in the rhythm, they understand that that needs to be fixed. So, you know, this whole monitoring of these rhythms and the temperatures and everything is going to create one ubiquitous network management system that's going to encompass everything. You know, we always talk about how, you know, OSS is going to be doing this, and this, and services. well, it will be overcompensating the whole thing. It'll be ubiquitous. And when we start to look at, there'll be hospitals will be the same kind of a function where there's going to be tons of IoT stuff in there and not manufacturing, but there'll be robots in there doing operations and needing that uniqueness as well, and understanding that, things have to happen very quickly. So, when we start to look at indoor coverage, we talk about Wi-Fi, we talk about 5G, and we also need to realize that LTE is still going to be around. It's not going to be gone permanently. IoT networking, robots, sensors, monitoring, motion sensors, cameras, all these IoT things will be inside these buildings. And this is going to create one important thing. It's going to feed this thing that we call the digital city. So the digital city mimics reality. So if you think about it, all the rhythms and all the patterns and everything goes into this digital city and then comes out and says, okay, all these people, when they go to floor 26, they walk down this way, they do this, they do this, they do that, so the road, so the whole digital smart city, digital twin city will feed the network management system that will go ahead and ensure that, the lifts go this way, that the moving stairs goes this way, and doors open. So it's going to be a whole new ball game. And people say, when is this going to happen? One of the things is with COVID and the touchless and everybody washing their hands, and their hands are sore now, so it's happening. People are saying, hey, we need to start doing this thing. And again, with all the security issues that we're having, again, that's also going to be driving this thing. So the buildings will also be made up of, data centers, cloud connectivities, all the blah, blah that we hear about. There'll be the overarching building management systems that we talk about that also include the HVAC, the lighting, the electrical stuff, securing rooms, securing infrastructure, so that, you think about it, you can actually create areas that are, personable for temperatures, and you can direct people who like, room temperatures of, say, 75 degrees, they can kind of direct them to this area of a large room, and they'll be comfortable. So this is all being thought about right now. There'll be a whole biometrics detection systems that'll be around. They'll be checking not just facial recognition, but body heat's coming off, because we know why. It'll be checking mass. It'll even be checking rhythms of people, arm sways, blinking, all the movements that are personal, because there'll be no more need for people to have, badges with their face on it anymore, or, something that, you have to use and show in front of a receptor, like something that looks at your iris or whatever. It'll all be done automatically, and you won't even know that, you're being tracked, because you're in the building, and you can meet all the security requirements and the data, the anonymous data information that is being, feared upon. People don't want to be captured, but if you're an employee, these are the things that can happen. And if you enter these buildings, there'll be ways of collecting this anonymously, and then when you leave, they can erase it. There'll be a whole traffic pattern flows will be built this way, and people movement and directions will be this way. Another thing of these buildings, it'll all be sustainable energy. What we talk about, sustainable energy, we talk about solar, but also wind power will be one of the biggest things. One interesting fact that I found out over the last few months was that, in Texas, oil is king, right? Everybody knows, in the States, Texas is big on the oil, but there are more people working in the wind sustainable energy market than in oil in Texas. So you can start to see that there is a pattern of, shifting away from fossils to, sustainable wind and solar, and wind will be a factor. Then we talk about this whole 5G environment, what will be made of several technologies, right? So the infrastructure, and this starts with the people building the buildings. We look at digital indoor antennas, we call them DASs. they support the 5G, whether it's passive or active. And no matter where you are in the building, you can use your mobile handset, you can use your laptop or anything to be onto this mobile 5G network, and you can be ensured this throughput that's always being promised. And Wi-Fi 6 will also, has a very close link and a transfer to the 5G, and everything's been approved almost pretty much for it to be seamless. And you'll start to see that being part of the service, such as, supporting the cloud and the IoT. So by utilizing the inside this building, there'll be LBS, there'll be the active DASs, there'll be these terminals, there'll be all these monitors. So this will ensure that we can use 111, and it's also going to help for supporting the vision impaired. I've seen systems already where for vision impaired now, when they go into a building, they just have to go ahead and set up their mobile phone with a couple of buttons, and it'll talk them through the building, whether you go left, right, and all these things. And here's the elevator and everything that it really needs to know to help them, face the challenges. And one other part that's going to be a crucial part is going to be these smart lampposts, which is what I'm trying to sell. These will deliver millimeter support. We talk about 5G, but we talk about 3400 5G and blah blah blah. We can do that, but we talk about cars that are going to have to stop on a dime, and autonomous cars. We talk about all these great things that are going to have to be responsive on a 1 millisecond delay and yada, yada, yada. But if you start to think about it, the speed of light, you just take a laser beam and shine it, you only go about 186 miles in a millisecond, right? That's just shining it in the air. Now, just think about going through actual fiber, communication huts and switches and all those things ain't that far away. So, we have to move things closer, right? We have to, come closer. We have to be in distances, I would say, if you think about it, you're looking at, 50 kilometers or so to get this 1 millisecond response. And even that's going to press it. It depends on the processing that you use. So it's going to be even closer than that. So it's going to require these smart lampposts to be situated outside of buildings. And one of the other parts is the conundrum is that as we build these buildings, we try to, make the glass so the light doesn't shine through it and all that ultraviolet protection. And guess what? 5G don't like that. It has trouble going through that glass. So there's another challenge that we face. And we face, how do we, satisfy those two? And things are being looked at, but again, it's another challenge that we need to look at. So I believe that these smart lamps are going to, contain the edge devices, so that therefore the IoT within the buildings can go ahead and report directly into this, and then fiber backhaul to where it's going to go to, to meet this challenge of this 1 millisecond, and especially. You don't want a car to have any more than that on a reaction. So again, if you come to a stoplight and that, autonomous vehicle, it needs to stop very rapidly. So there's going to be a lot of things that are changing. But we also have to remember that, we're going to support a lot of legacy out there as well. The Zigbee, the Bluetooth, the Wi-Fi, all that stuff. So, when 5G is rolled out, it's going to have to integrate into these technologies, rather than replace them and then slowly, like I say before, get rid of it completely and go pure 5G into the next generation. Again, with COVID and these pandemics and the security, all these things, it's going to be pushed to go quicker. So I think we'll start to see this stuff taking off in 2021 and then rapidly going to 2022, because the market's going to drive the technology. The technology will not drive the market. And, we look at this whole inherent physical, delivery of 5G, the certain environment instructions. So we need to analyze, the walls. So the thing is that we need to get developers and builders, as they're putting up these manufacturing plants, to understand more about radio waves, how it interacts, where the sensors are going to need to go. One of the things I found is that, in Australia, buildings that are over a certain amount of feet are required to start to use DASs and put them in. And right now we have electricians putting them in, and we need to get more people who understand the old RF and everything else. So I think we're still in the infancy stage, but we're rapidly becoming a baby. So there are a whole bunch of 5G, scenarios and technologies, and significant industry users that will enable this, right? So things like low latency, high bandwidth requirements for not just manufacturing, but for the medical, for the mining, for different industries. Massive IoT through the ability to handle the high cell densities. We're going to have massive amount of IoT out there. I've talked to one carrier, and they were saying to me that they fear that as IoT starts to be displayed and pushed out there, how many people are going to be changing it constantly. Just think about your mobile phone. Nobody keeps a mobile phone anymore. We don't, right, in the industry, for more than 2 years, right? Then we get bored, we want another one, and we pay $1,200, right? So can you imagine if you had to pay 10 cents for an IoT sensor? They're going to constantly be changing and upgrading and things like that. So challenging. There's going to be a huge challenge. How does the management systems and all these things that I keep talking about, how is it going to keep up with that to create this utopia environment that I'm talking about? So you have to understand that. And then there's going to be this ultra reliable security connectivity that needs to be installed and to be maintained. And we all know that the more security we put on, the harder it is to communicate. So we're trying to put a ubiquitous communication blanket all the way from the physical layer up to the application layer, which is a new kind of a concept. So today's networks are, when you look at today's networks, most of them are siloed, right? They got IoT networks, Wi-Fi, 4G, building management systems. We need to be completely ubiquitous, seamless, low delay, dense cell coverage. We need to be able to support that, as well as multiple applications to multiple users. And again, I think that as we start to look at this, things like slicing will be a very important part, where we can start to separate things, but keep them still on the same, it'll be separated virtually, and when you start to look at it, we can still run things through it. Right now, the way we separate things, we set up a VPN, and then we send it through the networks, and that's really a big waste, right? Setting up these VPNs. But if you can do slicing and bring it through the same wire and have multiple ones and no wastage, then you're talking about how we can actually support this whole area. So 5G is going to give the term smart manufacturing, smart building a whole new name, and people understand that it's about everything. It's about the internet, it's about thermostats, it's about lights, it's about occupancy. It's everything from 24/7. So some examples that I could talk about is really, again, it's going to be due to, say, the COVID that will drive some of these things that we start to see. We're going to see not just smart cities, but we'll see the smart manufacturing plants that will be driven by robotics from end to end, and very, very little human interaction will be needed. So, if you think about it, if you have a building, you walk up to the building, it would be able to sense, your temperature. It will be able to sense your body weight. You'll be able to sense most of your biometrics. and be able to take that information and allow you to enter the building and look up that, you prefer a room that's dimly lit, you preferred, things like, certain temperature, and it knows basically by your pattern that you always walk by the coffee machine, do all these things. And, so it'll be leading you through the whole way that you need to do things. So I don't want to go on and on and on, but, think about it. So this technology, not mature yet, but it's getting mature every day and the market's driving it. So I think that, this year, 2021, we'll start to see more and more happening now. And then 2022 become almost, the way of the chosen technology. So that's it for me. Thank you.
Excellent, Barry. Thank you so much for your time. Appreciate that for the explanation. Let's move on to the next speaker. Let me introduce Christian Wagner from Munich, Germany, to present on 5G private network for manufacturing.
Thanks a lot. I just tried to start my presentation. Just some words from my side. So I'm Christian Wagner, working for the mobile industry since 26 years now, in different positions at the mobile network operators, at vendors, and also as now at BAYFU. BAYFU is a company who is working and helping the industry to step into this new 5G world. And therefore, I want to give you some impressions and some insights, what this industry is interested about, and why do they do that? First of all, the digitalization is crucial for the future success. So they need to digitalize all the processes to be competitive in the market, especially the car manufacturers in Germany, which are huge in Germany. They are very banned to get more efficient, and this only can happen in digitization and in flexible production. And that's the key for the success story for the production. But we see there are many applications, so they want to do a lot, and they have very many ideas how to digitalize and how can we bring this from a wired communication to a wireless communication. But what we experienced now is that they have a very high silo thinking of the different different processes. So they have different technologies. They think, okay, this is an closed use case, and there is no scalability and no flexibility in this. But the question is, how does 5G make this world better? And which criteria are relevant to decide, yes, I want to make my 5G network, and yes, I want to change from unstructured Wi-Fi, Bluetooth, low energy network to an 5G network. Why and when and how can I do this? This is exactly what we find today in the industry. So we have Wi-Fi, we have the wireline, the Ethernet, we have Bluetooth, and these are all vertical processes and are very isolated. But what they need is they need a digital service platform. They need a unified platform where they can have a harmonized and orchestrated system that every use case they want to do is changed to one infrastructure. When I talk about one infrastructure, I do not mean only a 5G technology. I think Wi-Fi is also his existing rights in this ecosystem. Also the other like IoT communication systems like RFID and so on has their existing there. But you need to harmonize this and you need to orchestrate this. And this is the main part we see today is exactly the most challenging thing is how can I orchestrate this? How can I harmonize this? And how can I bring this in one ecosystem? We see a lot of use case requirements for the industry. I think everyone knows this. Yeah, AGVs, we have logistic things, we have enabled workforce, we have smart operations, we have these augmented reality glasses, what was described before. And they all have different requirements based on availability, based on latency, on bandwidth, and on density. When we go through our current projects we see there is not only indoor, this is also outdoor. So we have plants, we have campuses which have indoor and outdoor. Car industry, for example, has indoor maintaining, but the AGVs are driving from one hall to the other hall. And we see there is a lot of things which are happening outdoor as well. And then you need these mobility, then you need these handovers. So coming from an indoor to an outdoor, coming from an outdoor again to an indoor again, and with metal isolated walls, so nothing goes through. So and you have very hard handovers. And this is something which is very challenging, how to adjust your parameters, how to adjust, how can I optimize a network, and wireless network. And then we see, okay, so we have limitations. We have limitations in Wi-Fi. So the AGV is stopping when he drives from indoor to outdoor or other way around. We see there are limitations in Wi-Fi regarding the latency during this handover process. We see there is a bandwidth limitation there. And then we try to do this with LTE, because LTE is now, LTE is available, LTE is reliable, and LTE is affordable. And this is something what we tested a lot, making a handover within LTE. How many handovers do you need? Which handovers do you need? And we see there are also limitations. What we see now that 5G is really having a good progress on these challenges. So we see good progress here. And we hope and we think that 5G will be the answer of all these challenges and all these problems. The question is, does every use case need really 5G? So we have different use cases there, you can see, and you see that you can do a lot of use cases with LTE, and you can do use cases, but these are mostly the future use cases like augmented reality, virtual reality, not the future use cases which are now under testing, but in the real production, these are the future use cases. So these are on the start. But if they want to digitalize their current processes, the current use cases, they can start today and they can start now, and they can start with an affordable technology. As everyone knows, 5G is 2 to 3 times more expensive on the radio units for like LTE. And you see here is you can do a lot of today, and you can then move over to a 5G network. And this is exactly what we need, and where we are consulting all these companies, that we need an evolution from 4G to 5G. That once 5G is available in the wider area, and it's in the mass production, so you can get radio units affordable for an affordable price and in wide various radios frequencies, then I think there must be a way to change from an LTE to a 5G network. At the end, today we see we have different network options which are currently on the market. First of all, the network option when you go to a public network operator like Vodafone, like Telefónica, like Deutsche Telekom, and you say, okay, I want to use your public network, then the control plane, user plane, everything is at the national MNO. You can do this. You can do this with a DAS system in indoor. You can solve the coverage problem indoor with DAS. You can solve the coverage problem outdoor to use your private your mobile network operator. But what we see also on the market is more and more the semi-public. We call it the semi-public network, where the mobile network operator is giving you a slice or is giving you a part of this network, where he holds the control plane, where he holds the 5G core, and where he is putting dedicated radio units on the premises, and you can, with a MAC, with a data breakout, you can use the user plane as it is. And the third thing, which is most probably the most popular thing, is the real private network, where you have everything under your control as an industry. So you have your 𝗵𝗺 here, you have your 5G core here, you have your radios here, you have your own provisioning on the SIM cards. You can control your own performance, and you're 100% private, independently, and you're very flexible. Therefore, in Germany, for example, we have these private spectrums. We got 100 megahertz in the 3.7 to 3.8 gigahertz exactly for these options, or for this option. And we get now the 26 gigahertz spectrum, which is good, which is a big advantage in Germany, that we have a dedicated spectrum for the industry. And you can acquire this spectrum, but only for your area where you are the landlord. So, and this is normally, it takes, today it takes 2 to 3 weeks. So from acquire the spectrum, that you get the permission from the German authority, frequency authority, to use this. So this is a very good thing, which has positive things, that you have your own frequency spectrum and no one can use this, and your dedicated frequency spectrum. The other thing is you cannot use it for an area, for a region, for example. So for municipality or for communal authorities, they cannot say, okay, I want to use this for a part of the area of Munich. That's not possible. So it's only dedicated for the industry. Okay, so this is something where we see a lot of challenges, where we see a lot of opportunities. We are now active in different areas, helping them to find the right strategy in the industry, and see what and support them in the complete way, from the starting point, from having a use case, having the right business case, planning, selecting the right vendors, and then go over to the operations. So that's it for me. More information on our website. There are also some white papers for logistics and industries. Thanks a lot.
That was awesome insights, Christian. Thank you so much. I appreciate that. So now moving on to the Q&A session. We have a 10 minutes slot on the Q&A. So let's have a quick session. If anyone have any questions, maybe I can start first. We have actually brainstormed and discussed a lot of stuff when it comes to 5G, including the advanced manufacturing, the radio access network architecture, private network, the indoor building coverage, the AI, IoT, digital twins, and so on and so forth. My question is here is like, you know that when it comes to the telecom domain, when it comes to 5G, there's huge number of big players in the telecom industry, and also the small medium players. The open RAN solutions are coming in as well. At the same time, hyperscaler players are also coming in offering the edge solutions. Comes to Microsoft Azure, AWS, Google Cloud, and how we can able to see the clear line here, right? Because some says that the hyperscalers can be a threat towards to the telecom players, because now the hyperscalers has not only have targeted the market of the enterprise of telecom players, but also they are offering a good offer packages directly towards the mobile operators, right? So how does telecom players like Ericsson, Huawei, Nokia, others sees whether this is a threat, or is there because some of the companies like Microsoft, they claim that this is they are just a software company, they have nothing to do with the telecom, right? So anyone can able to answer on this?
I think there are different branches now on the way to deal with 5G and to offer 5G products. So the ones are the big vendors, the big OEMs like Ericsson, like Nokia, Huawei, and Samsung. Yeah. So they are here. They are clearly stated that they want to go to the industry market, and they offer products. They offer products, dedicated products, but also cloud products, yeah, where you can use these products and have a complete service, offer a complete service, a turnkey solution for that. You also have these smaller vendors. They are RAN vendors, they are core vendors, and they are, I think, they use this niche market because they are very flexible. So they are very flexible, so you can customize the network how you need this. You can start with smaller networks. So they have also their existing rights here. The third topics are the network operators. They now look for additional business models. Now the tariffs are not only in Germany, I think worldwide, they're going down to going down, and they have really challenges, and they want to have new business models and open new business models with 5G for the industry. So they are offering a good portion, a good shape of the network. They with the slicing, so you can get a slice for them, you can get a part of the network offered by them, but they also have the control about this. This is something what I showed in my slide before. And what we see today is that also a smaller cable network operator, they are thinking about, because they have existing customer in the industry, and their offer is an add-on. When you talk about Microsoft acquired Affirmed, which is a core network, core vendor. So they see the market. They can offer this with cloud solutions. This is a very interesting thing, and this could be very interesting for small, medium enterprises. So where they can say, okay, I have a small hall with 2,000 square meters. I want to make a 5G use case. Help me. Core is in the cloud, and what I have to do is install a radio.
Yeah, because I think they have acquired this Meta Switch, right? Because the Meta Switch has the capability the age solutions. You just need to plug a small box into any of the SMEs or industries, and they can able to offer such a good package prices, much more better offering than the mobile operators offers, right? So that's quite interesting. And any questions on the board?
Hi. Hi, Ganesh. This is Patrick here. Can you hear me?
Yes, Patrick.
Yeah. So I think with regards to your point on this, the web scalers and all, I think at the end of the day, there are many players in the whole value chain, right? So we have the OEM equipment makers like the Ericsson, Nokia, the Huawei's. So these are the, they occupy a certain portion of value chain, and then the carrier will occupy the spectrum value chain, and then we have the web scalers coming in to sit on top of the connectivity to offer the IT/application value chain, and then some of the application service provider are coming into the value chain. So to the point of your question is, I would say they are, there'll be some places where they might compete, some places they'll collaborate, but I think for the benefits of the entire ecosystem, I think it is a healthy competition. So this is just my point of view. What I think is kind of a challenge towards the quick adoption of 5G is the mindset change. What do you mean by mindset change? So for 5G to be adopted by the industry, we talk about ultra low latency. We talk about significant boost of bandwidth. The challenge when I meet with most enterprise is that they still view connectivity as very commodity, and they only want to pay commoditized fees for a very high value service level. All right. So I think this is a negative spiral. I'm not saying it from just the equipment perspective. I'm just saying it because it doesn't help the ecosystem. From the perspective that for most operators to offer those high availability, very high stringent service level to execute the use cases, a lot of investment has to go in. So it cannot be viewed as, you're just selling me a SIM card. It has saying that, you're selling me a slice of a capability, right? And this slice of capability can help you to enhance your productivity and as such. So I do have concerns when people talk about, you're too expensive, this is too expensive. It's not about, how a network is expensive, is how you use the capability in the right use case to deliver the right benefits. So this is how I usually like to position the discussion. Yeah. Thanks.
Thank you, Patrick. Any other questions?
And by the way, Christian, I enjoy your topic a lot.
So yeah, I think it's already like 6:15, right? SGT time. So the session has now come to an end, and I hope it was beneficial to everyone. And I would like to express thank you. I'm so appreciate to your time and effort for today's session. And this session will be uploaded in YouTube in a couple of hours. And let's keep in touch via the LinkedIn. It's a small world, and I hope we can able to have some sort of who knows, we can have a partnership in future. Anything comes along the way, let's keep inform each other. Thank you so much. I appreciate for you guys.
Thank you for invitation. I'm glad to be on this panel. Yodi, Ganesh, Christian,
Thank you.
Najib.
Thank you for this.
Thank you
you
so
guys.
much.
Thank you.
Thank you very much.
Appreciate-
Thank you for the
appreciate
Thank
time.
you.
Bye.
Take care.
Bye-bye.
Bye. Bye.
Bye-bye.